The longevity of XMM was not foreseen. It just kept right on going.
Something about looking at the night sky that just fills you with a sense of wonder, and I just never grew up from that.
XMM has been a part of my career from the earliest stages even until now.
XMM is a space-based observatory that studies X-ray light from the most energetic phenomena in the universe. It spans the range of everything from studying energetic stars and exoplanets around those stars to the most distant universe.
We can start with comets, which are very cold objects. We go then to compact objects where we observe very hot plasma near to the event horizon from a black hole. And then completely different then we look in XMM-Newton data for signature of dark matter. And this, I think, makes this mission so great, that it allows such a broad science to be addressed.
I had a sabbatical in 1982 in the United Kingdom, and my office mate at the time was Steve Kahn. We had a third office mate, was Keith Mason. We came up with the idea that it would be great to do multi-wavelength observations from space, to do deep X-ray imaging and spectroscopy, and simultaneously be able to observe cosmic sources in the ultraviolet and optical bands. If we could do all this from one platform in space, namely XMM, it would be much more efficient. Then when the X-rays saw something pop off, the ultraviolet optical telescope would be right there, seeing it right away.
XMM-Newton is a really fantastic telescope. It's more than just one telescope, actually. You can study the same object across a range of energies, from the optical, where we can observe from the Earth, up into the UV and X-rays, where you really have to go above into space.
It was great to be at the beginning of multi-wavelength astronomy. There's virtually no cosmic sources that just radiate at one frequency. And when you look at the universe with X-ray eyes, you see something much different than when you look at the same universe in ultraviolet eyes.
I led the US piece of one of the three major instruments on XMM-Newton, which was called the reflection grating spectrometer. I developed the initial concept for that in the early 1980s when I was quite young. We knew that many systems in the universe emitted X-rays copiously, but we didn't have very detailed models for how that X-ray emission arises and what it was actually telling us about the systems.
Spectroscopy is the study of light emitted by atoms, but it's more than that because atoms are peculiar. When they shine, they don't just give you all the colors of the rainbow. It looks more like a barcode.
You get very sharp peaks at very particular wavelengths and frequencies, and those are associated with particular quantum states.
It's extremely powerful. It's just like a barcode. It looks like a bunch of garbage to human eyes, but it can tell you, what's in a product and how much it costs and what country it came from and all that stuff.
By measuring that detailed pattern, we can learn about the fundamental physics of what's happening in these very exotic environments. What the temperatures are, the densities, the pressures. The spectroscopy that XMM-Newton did really answered a huge number of questions.
With the most recent result with XMM, we were able to measure the spin of the black hole. And I liked the signal so much so that I put it on a cup and I drink from it every day. So
My son was shocked that other people in the school were knowing XMM-Newton. Small children from 10 years that they know that XMM-Newton is an X-ray satellite.
It was amazing. It's like the Cal Ripken of satellites, of space satellites, this thing that just keeps going and going and going and producing great data.
I'm delighted to see that, number one, the mission is still working, the instrument is still working, and that there are all these young scientists that have been inspired to figure out great things to do with it.
And they're using it in all sorts of ways, which is really amazing to see a telescope used in ways and for discoveries that you could never have predicted when you first were designing it and launching it.
There's certain science that XMM can do that other X-ray observatories can't. Recently, XMM has invested lots of time in these large area multi-wavelength survey fields, including work that I've been leading in a region of the sky that has lots of existing data. And that multi-wavelength data is really important to harness the best scientific results out of XMM.
Astronomy is going through a revolution. There's gravitational waves detected, there's several kinds of weird supernova detected, and having an X-ray instrument to simultaneously operate while these optical instruments are operating would be extremely beneficial.
Many objects change. They have flares and outbursts, so it's really a key observation to have everything from the X-ray, the optical, and the UV all precisely at the same time.
I'm so glad that XMM is a part of that it was taking people originally into the directions of the time, and today is taking people into entirely new directions.